What's up YouTube? Welcome back to another row math video. So today I have for us a little interesting forces problem. And there's some kinematics in here as well. So in this problem we have a bucket, and that bucket's being accelerated by a cord of negligible mass. Oh my god. And the braking strength is 75 newtons. So the maximum pulling force we can exert on it is 75 newtons. If the bucket starts from rest, what is the minimum time required to raise the bucket a vertical distance of 12 meters without breaking the cord? So there's a little kinematics problem here at the bottom, and the only variable we're missing to solve for time is the acceleration. Now here to the right, I have a little free body diagram of the bucket, and there's a tension force acting on it and gravitational force, the weight. And in order to solve the acceleration of the system, we first need to write down the summation of forces acting on the object. So we know that the net force acting on this bucket is just going to equal the tension force minus its weight, and that's going to be tension force minus mg. And this is a net external force, and that's going to cause an acceleration, a net acceleration. We know that the maximum pulling force that we can exert on the string is 75 newtons. And the weight of the bucket itself is going to be 5.6 kilograms times 9.8 meters per second squared. And that's going to equal ma. Now to solve for this maximum acceleration, we are going to divide both sides by the mass. So that's going to give us 75 minus 5.6 kg times 9.8 meters per second squared, all over the mass, which is 5.6 kilograms. Now let me just do a little computing over here on the side with my calculator. So 5.6 times 9.8 minus 75 divided by 5.6, I get a total of 3.6 meters per second squared. So this bucket is going to be accelerating 3.6 meters per second squared upwards. Now, in order to solve, so this is the maximum acceleration. So from that, using that, we can find out the time it takes for this bucket to travel 12 meters. That's what it's asking for. So over here to the side, I'll just do it up here. We know that the displacement is going to equal, because we have no initial velocity, it's just going to be 1/2 the acceleration times time squared. And then we know t squared is just going to equal to 2 change in y all over ay, which is just going to be, the distance is 12, so 2 times 12 is 24 meters, all over, the acceleration is approximately 3.6 meters per second squared. And then taking the square root on both sides, we get t is going to equal, now let me just do a little computing over here. Okay, we get t is going to be approximately 2.58 meters per second squared. And that is our answer. Future Roman here, you know what I meant. 2.58 seconds is the answer. Thanks for watching, and please leave a big fat like on this video, and don't forget to subscribe. Thank you.